can start. It's for you to start now.
Awesome. Thank you very much. Just getting set up here. Okay, here we go. Can you guys, let me just share my screen here. Can you guys see my screen?
Yeah, you can.
Awesome. Okay, let me just go to step one. Awesome. Okay, well, hey everyone. My name is Ben Weinberg. I'm a developer advocate with the Axelar team. I'm calling from Toronto, Canada. So a long way from India, but really appreciate you guys taking the time to come listen. Hopefully next time we do this, I'll actually be meeting a lot of you people in person in India. But for now, this will do. So a bit about myself. All right, before we go to myself, I just want to go over the brief agenda for today. So we're going to start off with the need for interchain, how we got here, why this matters. We're going to go over the problem with pairwise bridges as they've existed over the past few years. Then we're going to get to the Axelar network, an overview of the Axelar network and the advantages which it brings to the table. We're then going to get into a really cool feature called general message passing, otherwise known as GMP. We're going to go through a brief code example of GMP. And then we're going to end off with Axelar in the wild and some brief stats about the Axelar network as it's running today. So lots to get through. So let's get right to it. So a bit about myself. I got into the space back in end of 2017. And for myself, as a new person in the space, I would go to a lot of events and conferences and meetups. And I'm sure many of you have had a similar experience to me when you were going to these events for the first time. You know, you go to these events and like everyone seems to know a lot more than you do. Everyone is very opinionated, very confident. Many of the times they're promoting projects which you've never even heard of. And for myself, back in the day when I was going to these events, these were some of the big projects that were being promoted. There's, of course, Ethereum, which was the biggest project back then as it is today. But in addition to Ethereum, there are other projects which some of you may have heard of, such as like Neo, IOTA, Tron, EOS, and many of the people at these events where I go to would be promoting these projects in different ways. And the idea that the branding which many of these projects took were different. So there was Neo, which was branded as like Chinese-backed version of Ethereum. There was EOS, which was branded as Ethereum on steroids because it was faster and cheaper than interacting on Ethereum. And many of these projects were known as like Ethereum killers that I have on stage here. And there was this idea, this mindset this idea
Yeah, sorry.
will rule them all
We
is wrong.
we lost you in between. Sorry.
That's okay.
Yeah, you can start now. No, it's fine.
We're good?
Yeah, we can.
Okay. Let me just share my screen again. Cool. Where did you guys have me? We get the chain maximalism?
Yes, we were here only. That's when we lost you.
Okay, yeah. So basically, all what I was saying here was that this idea of one blockchain to rule them all, of chain maximalism, never really happened. Rather, what we've seen is the rise in the number of blockchains that exist. So this is a little screen share I made a few weeks ago from a website called chainlist.org. Some of you may have heard of it or have even used it before. But basically, what this website shows is a list of many of the blockchains that exist today. And I say many, not all, because it's impossible to actually say specifically how many blockchains exist. But you can see here just on Chainlist, there's hundreds, if not thousands of blockchains. And you can see many of these blockchains are optimized for different use cases. Some are optimized towards like privacy, some are optimized towards security, some towards speed. We've seen the rise of like app chains, and these are app chains are like blockchains that are optimized for like one specific application's use case. And with the rise, and I'm sorry, I know this is easy to make you dizzy, so I'm gonna pause the video here. I think you guys get the point. But what I'm trying to show you here is that with the rise, there's a fly in the room, with all these blockchains that exist today, for our space to really be successful, we need to be able to connect many of the different blockchains that exist today, because there's liquidity on different blockchains, there's communities that are loyal to different blockchains. So for us to succeed, we need to be able to interoperate between these blockchains. And what we've seen over the past few years, this is not a new realization that interoperability is important. What we've seen has been the rise of like these pairwise bridges. And what these bridges allowed us to do were to send wrapped assets between blockchains, or to use wrapped assets on different blockchains. And these wrapped assets, for those who aren't familiar, are basically derivatives of a certain native token. So we saw the rise of tokens like WETH, wrapped Ether, or WBTC, and these tokens are tokenized versions of the native asset they represent. So one WETH is equal to one ETH in terms of dollar value. And it was great because you could use your WETH on a different blockchain as if you were using your native ETH, even if it's not actually your native ETH. And the same with WBTC. The issue with many of these bridges, though, is that many of these bridges were using something called a multi-sig contract to basically validate transactions between chains, or to handle transactions between chains. And for those who aren't familiar, very quickly, I'm going to go through what is a multi-sig contract. A multi-sig contract is basically a design pattern that allows you to guard a transaction from being sent from a specific address or a specific contract, unless a certain amount of signers have signed on the transaction. So in this example here, we have 4 potential signatures: myself, my younger brother, and my parents, who didn't want their pictures being used here. But in this example, we have a 3 of 4 multi-sig. So what does that mean? It means that 3 of these 4 people need to sign off on the transaction, or else it won't be executed. And if 3 sign off, then we're good to go. And this is great because it really helps with security. In some cases, you don't want just one person signing off on the transaction. You lock it to a certain amount of people. The problem here is that for bridges that are sometimes holding hundreds of millions of dollars, this is not secure enough. And we've seen some of the most famous hacks in the entire Web3 space have been from attacks on bridges. You can see here some of the more notable headlines that have occurred. The most famous one, some of you may have heard of it, was the attack on SkyMaps' Ronin network bridge. For anyone who's played Axie Infinity before, you probably have heard of this. This was a $625 million hack. A hack that happened earlier this summer was on the Poly network bridge, which was a 3 of 4 multi-sig, basically the exact use case I showed you before, whose the keys of the multi-sig were compromised. So the network got hacked. And on the bottom here, there's some other hacks. There's many, many more hacks I could have included here on this slide. And an interesting article by a company called Chain Analysis came out about a year ago. They estimated that in 2022, 69% of total funds stolen in the entire space came on attacks on bridges. And that's about $2 billion worth of funds that were stolen. So if we pause right here, what do we know? We know that chain maximalism is wrong. We need interoperability between different blockchains, but the way we've conducted interoperability on a whole as a community can be improved from what we've had over the past few years. And that is where Axelar comes in. So what is Axelar? In its simplest, Axelar is a blockchain that connects blockchains, enabling universal Web3 interoperability. And that's a bit jargony, so let's unpack this quote here a bit. And I want to focus on these last 3 words here: universal Web3 interoperability. So the easiest way, I'm going to full screen this. The easiest way to view Axelar is with this diagram right here. It's a hub and spoke model. So in other words, any blockchain here that wants to connect to each other, that wants to connect to another blockchain, goes through the Axelar network. And remember, it's universal Web3 interoperability. Those are the 3 words I wanted to focus on. And why am I focusing on that? Well, if you look at some of the projects here that are actually connecting via Axelar, we got projects like Ethereum, Polygon, Avalanche. These are examples of EVM, of blockchains that are running the Ethereum virtual machine. But what we also have, in addition to EVM-based blockchains, we have like Osmosis, Juno, Crescent, the Cosmos Hub. These are examples of blockchains that are built with the Cosmos SDK from the Cosmos ecosystem. And these are also now connected to EVM blockchains and to each other. We also have projects like Arbitrum. Now we also have Linea, we have Base, even though those 2 are not on this diagram. Those are examples of layer 2s that are also now connected to each other via Axelar. And there's this idea of universal Web3 interoperability. It doesn't matter the consensus mechanism, it doesn't matter the virtual machine. As long as you're plugged into the Axelar network, you can now connect to any other blockchain that is also connected to the Axelar network. And there are two major improvements that come when you use Axelar right out of the box. There are scalability improvements and there are security improvements. And I'll touch on scalability briefly first. So remember, Axelar uses a hub and spoke model. So any blockchain can just connect to the Axelar network and then to any other network. Let's contrast that with pairwise bridges. Let's look at this example here. We have three blockchains. We have Ethereum, we have BNB, and we have Polygon. If I want to connect to each blockchain, you can just count the arrows here. We have 6 bridges connecting each blockchain to each blockchain. For 3 of these blockchains, we have 6 bridges. Let's say I want to add a 4th blockchain. Let's call it Avalanche. Now, for just one more blockchain, for a 4th, we now have 9 bridges. So you can see that the number here for each new blockchain does not scale very well. Imagine we wanted to connect the thousands of blockchains that we saw a few minutes ago on Chainlist. How many bridges we'll need to connect each of these blockchains? Now, if we look at Axelar, we don't need connection from each blockchain to each blockchain. All you need is a connection to the Axelar hub, and you are automatically connected to each of the other blockchains that are also connected to Axelar. So in terms of scalability, it's a tremendous improvement from this design that we saw here earlier. The next major improvement that we have in addition to scalability is security. And now let's focus on this quote again, this time to the top line. Axelar is a blockchain that connects blockchains. So how does this help for security? Well, as a blockchain, Axelar is running the proof of stake consensus mechanism. It's built with the Cosmos SDK. It's currently running 75 live different validators. And these here are some of the validators that are maintaining the Axelar network. Anyone here familiar with the Cosmos ecosystem might be familiar with some of these validators. We got like Figment, Informal Systems, Pikachu. These are reputable validators that are maintaining many other projects within the Cosmos ecosystem as well. And you can see having an actual blockchain to handle the interoperability layer of Web3 is a tremendous improvement on the security front from what I was showing you guys earlier, from having like a 3 of 4 multi-sig that's handling all transactions between different blockchains. Now we actually have an actual blockchain which is handling all these transactions on the security front. So it's a tremendous improvement from what we saw before. The next thing I really want to get into is an exciting new feature that's come out called General Message Passing, otherwise known as GMP. So what is GMP? This is where we really discover the true power of interoperability. So if you remember what I was showing before, what we could do these past few years has been like using wrapped assets on different blockchains. And this is cool and very powerful, but we want to do more with interoperability. What general message passing allows us to do is to actually send messages between blockchains in addition to just using assets. So you can see in this example here, there's myself here on Ethereum and myself on the Avalanche blockchain. And I'm sending a message from Ethereum to Avalanche saying like, hey, WAGMI, are we going to like make it in this crazy, amazing space of ours? And now from Avalanche to Ethereum, I'm sending another message called SafeMint 5 Bored Apes. And what I'm trying to show you guys here is that in addition to actually just sending like kind of silly little hello world messages, what we can also do that's really, really powerful is call functions between different blockchains. And that to me is true interoperability. The idea that we can interact with contracts and by extension functions on contracts as easily on different blockchains as easily as we could interact with them on our own blockchain. So I from Polygon or from Avalanche, let's say, can call a function on Ethereum as easily as if that function was also living on a contract on the Avalanche blockchain. And let's go through a very brief diagram of how this actually works. So imagine we have a dApp that I've deployed on 2 blockchains. And we're going to look at the bottom here. So I have my dApp that lives on Avalanche, and I have a dApp that lives on Polygon. Okay. Now I want to send an ERC20 token from Avalanche to Polygon, my dApp that lives on both blockchains. So let's go through this step by step. The way you want to interact with the Axelar network, or the way you need to interact with the Axelar network, is via something called a gateway. A gateway is a contract that is deployed by the Axelar team. It lives on every single blockchain that is connected to Axelar, has a gateway contract deployed on it. So you as the developer just need the address of this gateway contract, and then you can interact with it. This gateway contract exposes many different functions, which you can use. One of these functions is call contract with token. So you have your dApp, on Avalanche, you want to send this token. So you import the gateway, you run this function called call contract with token. Once you call this function, the gateway contract will pick up on this, and the gateway contract will then emit an event. This event is then submitted automatically to the Axelar network. Remember, the Axelar network is a blockchain, which is being maintained by validators. The validators come to consensus about the message that was sent from the source chain, from Avalanche. If they come to consensus and say, like, yes, you really did send this message, then they mark that message as approved. That approval message gets sent to the gateway contract on our destination chain on Polygon. And then once that gateway contract receives that approval message, it, via something called a relayer, will trigger the execute with token function, which will be written out on our dApp on Polygon. On that execute with token function, we will receive the payload, which is our message that was sent from one blockchain to the other. And we'll go through a code example so you can see how this all works. I know this is a lot to take in, but all we really have to understand here is we have a dApp on 2 blockchains. The dApp on the source chain on Avalanche triggers the call contract with token function via the gateway. The gateway emits an event. The event goes to the Axelar network. The Axelar network validates the event, sends that validation to the gateway on the destination chain, and the gateway calls this execute with token function, and then this execute with token function computes or runs some logic with that message that was sent. So let's see this in action. Cool. Find my code here. Okay. So for time's sake, I'm going to flip between branches here to show you how this code is built. But what this code is going to do is basically implement the example that we just showed on the previous slide. Okay, I want to have this open so I can flip it back and forth. Okay, so let's go through this code. First thing we want to do is import our ERC20 interface from OpenZeppelin. Pretty standard stuff here. This code example will be live. You guys can have it at the end. The next thing we want to do is import, sorry, let me close this a bit, is import our exit. Can you guys raise your hand if you can see the code, or do you want me to make it bigger?
I think so. It'll be nice if increase the size. Yeah.
Okay, yeah. Is this good or bigger?
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 Bigger. A little bit bigger. Yeah, perfect.
Perfect. Okay. Let me actually full screen this. Okay. Sorry about that. Okay, we're happy with this. All right, I'll have to scroll a bit on my monitor so you guys can see this. But yeah, so what I was saying before, the first thing we do is import the ERC20 interface. The next thing we want to do is import something called the Axelar executable, which I will explain this later. You can ignore that for now. The next thing we want to do is import our gateway interface. Does anyone remember the gateway contract? That is this guy here from our example, our gateway. So we import the interface for that so we can interact with the functionality on the gateway. Next, our final import for this contract is something called the gas service. Now, the gas service is a really important tool which Axelar enables for us. Remember, I said when we're interacting with Axelar, we need to interact with the gateway. The second contract we're going to need to interact with is called the gas service. So what is the gas service? Well, let's think. Axelar is a blockchain of blockchains, and we are sending a transaction from one blockchain to another blockchain. So if we think about that, that means we'll need 3 tokens just to send an interchain transaction. Let's say we're sending from Avalanche to Polygon. So we need AVAX, which is the token of the Polygon blockchain. We'll need AXL, which is the token of the Axelar blockchain to pay the gas on Axelar. And then we need Matic, or Poly, which is the network of the Polygon blockchain. So that's 3 tokens that we need just to send an interchain transaction, which I don't know about you guys, but I don't want to have to hold 3 tokens every single time I want to send a transaction. It's pretty annoying. So what the gas allows us and our users to only need to pay the gas on the source chain. And then the gas service handles the payment on the Axelar blockchain and the destination chain. So for example, if I'm sending from Avalanche to Polygon, all I need is AVAX. I pay AVAX to the gas service, and then I'll tell the gas service, hey, I need gas from you for the Polygon blockchain. So the gas service will pay the gas on the Axelar blockchain and on the Polygon blockchain. So me, I only need the token of the first of the source blockchain. And we'll see that in action. And it makes life much easier. now we only need 1 token instead of 3 tokens. Just to clarify our pocket in the end of the day, but it just comes out in the form of AVAX. We don't need to hold the other 2 tokens. So let's move on here to step 2. Very simple stuff. First thing we do is we have our constructor function. We pass in the address of the gateway contract and the address of the gas service contract. Remember, it doesn't matter what blockchain you're on. If it's connected to the Axelar network, it will have a gateway contract and a gas service. You just need to look for in our docs for the address of these 2 contracts. Step 3, we now define our send to many function. This is the function that we're actually going to be using here to trigger this demo. It takes 5 parameters: the destination chain, the destination contract address, the destination addresses, the symbol, and the amount. So what are these 5 parameters? The destination chain is basically just the name of the blockchain which we're going to be sending to. So if we're sending from Avalanche to Polygon, then what we're going to pass in here when we're calling this is Polygon, the name of the destination chain. We're then going to pass in the destination contract address. Anyone know what that is? That is going to be this contract, which will be deployed on both the source chain and the destination chain. So we're going to have to basically say like, hey, once we're on Polygon, which address is going to handle this transaction? That is what we're going to be passing in here. So deployed on both networks. Next is the destination addresses, which I will come back to this. We can ignore this for now, but I'll explain this in a bit. The next 2 parameters are the symbol of the token which we're sending and the amount of tokens. So how many tokens are we going to be sending and which token are we going to be sending? So if we go to step 4, and I have not forgotten about this, I promise we will talk about this very soon. So let's start writing out this function. First thing we want to do is require that message value is greater than 0. This is basically saying like, hey, if we haven't sent any funds to this contract, then revert and say like, hey, we need gas to handle this, to pay for the transaction. If there's no gas, revert. Next, we're going to, with our gateway contract, pass in the symbol of the token that we're going to be sending. So in this case, we're going to be passing in a wrapped version of USDC. So we just pass in the AUSDC symbol, and then the gateway is smart enough to query the address of the token. All we need to do is pass in a symbol, and now we have our token address returned to us. Next, with our token address, we're going to be running 2 standard ERC20 functions. The first is the transfer from function, and the second is approve. So what we're doing here is basically transferring the funds from me to this contract. And we're going to be approving the gateway contract to be handling these funds for us. Basic ERC20 stuff. Next, we'll be encoding our destination addresses. So that is this 3rd parameter, which I promised I'd come back to. So what are we doing here? We're sending an ERC20 token from one blockchain to another. But in addition to actually sending that ERC20 token, remember, the whole point of this example is to show you GMP, general message passing. So we're going to be sending, along with our token, or tokens, I should say, a message. Now, what is that message? That message is going to be this 3rd parameter, destination addresses. And what we're passing in here is a list of addresses who are going to be receiving this token on the destination chain. And to actually send a GMP message via Axelar, we have to encode that message, which is what we're doing here. So what are we going to be doing? We're going to be sending, like, let's say 6 USDC from Avalanche to Polygon. And then once we receive those USDC, we're going to actually be sending those tokens to these addresses that are sent here. So in addition to sending tokens, we're also going to be running some logic with our GMP message. And we will see that later on in this contract. So all what we're doing here in this final step is encoding this message that will be sent to the Axelar network. Now on step 5, we will finish off this send to many function. Remember, we're still on this function this entire time. And we're going to be actually triggering some logic from our gas service and our gateway contract. So with our gas service, we're going to be doing what I said earlier. We're going to be specifying like, hey, which blockchain do we need gas for? And who is paying this gas? So that's what we're passing in here. We're calling the pay native gas for contract call. We're going to be saying like, hey, I'm paying the gas and we need gas for the Polygon blockchain. And then we're going to be calling our gateway contract here. So the gateway contract, remember, exposes many functions, including call contract with token. If this sounds familiar to you, that is because that is the function that we had here on our slide, call contract with token. We're actually calling it here. And what we're passing in is all our parameters from before. We're passing in the name of the destination chain, the destination address, the recipient addresses, which is our GMP message that we encoded up here, and then our symbol and our amount for our ERC20 token that we're sending. Next, we're going to define our third and final, or our second and final function here, which is our execute with token function. If this looks familiar, that is because that is this function right here. So at this point, when this function gets called, we're going to be on Polygon. We're going to be on our destination contract. So let's go through the flow. We call send to many. Send to many goes through this logic and eventually hits the gateway contract. With the gateway contract, it'll call contract with token. That now triggers a message that goes to the Axelar network. The Axelar network handles the transaction. And then once the transaction is handled on the Axelar network, on Polygon, we will be executing this function automatically. And what do we want to do with this function? Well, let's go to step 7, our final step. We're going to decode the payload, which is a parameter that comes in here. Does anyone want to guess what the payload is? The payload is this magic third parameter. It's our GMP message. It's our list of addresses. So remember, we send the token and we send in a list of addresses. We encode the list of addresses, goes via the gateway contract here through the call contract with token function. Then it comes out the other side here as payload. We decode the payload, and now we have a list of addresses. And what are we going to do here? Well, first we pass in our token symbol. We get our address of our USDC token or AUSDC token on the Polygon blockchain. And then we run some super simple logic. We take our amount of tokens that were received. We divide it by the length of addresses that we received. And now we have the amount of tokens that we need to send to each address that is receiving the token. And then we loop over the list of addresses and we transfer each token amount to each address. So let's say, for example, we send 6 tokens and 3 addresses. On our execute with token function, we decode the 3 addresses. We then take the 6 tokens that we sent divided by the 3 addresses. That gives us 2 tokens for each address. And now we transfer 2 tokens here to each address. So let's actually execute this. I'll make this a bit bigger so you guys can see. We're going to run this very simply via the hard hat CLI. So first thing we're going to want to do here is run our deploy script, which for time's sake, I'm not going to go through it. But basically all what it's doing is taking this contract and deploying it on both the Avalanche and the Polygon blockchain. So let's run this. It should console log 2 addresses for us. And live coding, so bear with me. So it's deployed on Polygon here at this address, and hopefully in a second, we should see it deployed on Avalanche as well. Great. So now we have this contract, which is deployed twice on Polygon and on Avalanche. Next, we will open our hard hat console on the Avalanche blockchain. So let's wire up this contract here very quickly. We call the Ethers contract factory for our GMP distribution contract. That is the name of this contract. You can see defined right here. And next we will wait contract.attach the address so that we can interact with it. So we grab our address from Avalanche, we attach it here to our contract factory. And now we can hopefully interact with this contract. So let's try out something. We have a public variable called gas service here. So let's call gas service and hopefully it returns an address. Cool. So now we're actually talking to our contract on the Avalanche blockchain, which is pretty cool. So what do we want to do? There's only one thing we need to do. We need to call send to many, this function here, to actually trigger the transactions. So let's go await contract, our variable that we just defined, send to many, and we need to pass in 5 parameters. Remember what they are. Let me make this a bit smaller so you guys can see. We need to pass in the destination chain, which is Polygon. That's where we're sending it to. We need to pass into the destination contract address, which is this address right here, which we deployed earlier on Polygon. We pass that in. We then pass in a list of addresses. So I have this list right here. So I'm going to paste in these 3 addresses that we're sending the token to. We then, so let me go back, want to pass in the symbol of the token, which is AUSDC. This is the token that we're sending. Then how many tokens are we going to send? Let's send 6 tokens, which is USDC, 6 million, 600,000, 6 million. It's just 6 decimal points for USDC. It's why we need 6 million. And then the last thing we want to do, or we will get an error, is pass in some gas. So I have this right here. This is 0.1 AVAX. So hopefully, if I didn't mess anything up, when I call this big blob of code, send to many Polygon here, we really, really cool feature which Axelar has available for us called Axelar Scan. Axelar Scan is the block explorer, kind of like Etherscan is for Ethereum. Axelar Scan is the block explorer for the Axelar blockchain. You can see here a bunch of stats on Axelar. You can see the latest model here of all the blockchains that are connected to Axelar. What we want to do, let me go on dark mode here, is paste in up here the transaction hash that we got. And hopefully this should work. If we give it a second, it loads up our transaction. Let's see what's going on here. Try this again. There we go. And you can see here, what's really cool is all the different steps of an interchain transaction. All the steps that I showed you guys from this diagram here, you can see taking place on Axelar Scan. So you can see the first step, the transaction gets sent from Avalanche right here. I could even click on this little, let me make this bigger for you guys. I could even click on this little Avalanche logo here, and this takes me right, I don't know why it's moving so slow, but it takes me right to the Avalanche block explorer. I could see every transaction taking place on the native block explorer that we're using. Then the gas gets paid on Avalanche. That's step 2 right here. Then it gets confirmed on the Axelar network. That's step 3. It then gets marked as approved. And that gets sent on Polygon Scan. You see here at this point, we're on the Polygon block explorer. That now gets sent to the gateway contract on the Polygon block explorer. And then our final step gets executed on Polygon. So if I click on this transaction here, you can see all the gas getting paid as well on the different steps of this transaction. And you can see all the 5 different steps. So if I click on the final step of executed here, you can see it takes me right to Polygon Scan. And you can see the 6 tokens are sent and they get divided 2, 2, 2 to each of these 3 addresses that we sent. If these 3 addresses look familiar, these are the 3 addresses that we pasted in our hard hat CLI right here. This one, and this one. So you can see it worked. We have 2 tokens that are now sent on our destination chain based on the transaction that was sent from Avalanche to each address. And that is GMP in action. I know I'm a little low on time, but there's some really cool things I wanted to show you just before we wrap up here. So I hope that was clear. What I want to show you guys now is Axelar in the wild. What are some applications that are live today that are actually using Axelar? The most interesting one, in my opinion, or the most exciting one, is one called Squid. Squid, this UI might look familiar to you guys. For anyone here who's used Uniswap before, anyone? Are we all familiar with Uniswap here?
Yep.
Yeah. Yeah. What Squid allows us to do is like Uniswap, where we can actually swap tokens between different contracts. With Squid, we can also, in addition to swapping the token, we can swap the tokens between different blockchains. So you see here, unlike Uniswap, where I only pick the token, I also pick the blockchain. So here I'm swapping between GRT on Ethereum to USDC on the Optimism blockchain. Another really cool new use case that's coming out is the interchain token service. This is a very brief video. What the interchain token service allows us to do is to deploy an ERC20 token on many different blockchains in just one click. And then those tokens that are deployed on many different blockchains can be sent between the different blockchains. It can also be used for if you have a token that is already live on a blockchain and you want to have it deployed on other blockchains, you can also do that. So you don't have to deploy a new token. So let's see how easy this is. First thing I want to do here is, is define a token. So I give my token a name, I give it a symbol and some decimal points. I then register the token. You see, I'm doing it on Avalanche here. My next step is I wanted to pick which blockchains am I going to be actually deploying this token on. So in addition to Avalanche, I select like Polygon. I can select many other blockchains as well. I call deploy and register. My MetaMask transaction pops up, and then you see it gets registered on Avalanche and Polygon. And then if I want to deploy it on Ethereum or Moonbase or Phantom later, I can do that as well. So let's see, right now I want to deploy on Arbitrum. So I select Arbitrum, sign a new MetaMask transaction, and now it's also deployed on Arbitrum and BNB. So you can see how easy it is to deploy interoperable tokens on different blockchains. So this is a feature which is already live on testnet. It will be live on mainnet very soon. The last thing for me I want to end off with here is a brief view of the Axelar stats. You guys might be familiar with this. This is Axelar scan. We just looked at this earlier in our example. And what I want to show you guys here is just some of the numbers using Axelar. And we're just about done. This is the last thing for me. You can see here we have 103,000 general message transactions that have gone through. We have $4.5 billion of transaction volume that has gone through. We're on 49 different blockchains that you can connect seamlessly today. And the exciting thing, like these very large numbers, this $4.5 billion, this is only in the last 30 days. So you can see it's a very, very exciting time to start learning how to use Axelar. Many people are already using Axelar. It's an exciting time to learn how to use this tech stack. And yeah, if any of you want to look up the coding sample or other examples that we have, you can scan these QR codes. On the left here is a really good YouTube channel that we have, videos explaining both the example I just did and other cool examples as well. On the right is code examples. This will take you right to our GitHub page. And you can see end-to-end examples with a front end of doing things like I just did, like sending an ERC20 token, but also many other use cases with Axelar. So if you're interested in this stuff, I highly encourage you guys scanning these 2 QR codes and start playing around with it. This is how I learned to do this stuff. Thank you very much, everyone. My name is Ben Weinberg. If you have any feedback for me, how we could make this talk better, how we could help you more with things you guys liked, things you guys didn't like, you can let me know. Send me an email whenever. I'm happy to talk if you guys have projects you want to start building with Axelar. And thank you very much, everyone.
Thank you, Ben.
That's it for me.
You have anybody any questions? Okay. All right. So guys, Axelar is also giving out grants of our founders here. Whoever is interested, you guys can reach out to Axelar, or we'll be sharing a link. If you guys are interested, you can apply for those ecosystem grants. All right. Okay. Thank you, Ben.
Thanks for listening, everyone.
Ben, we have one question.
Oh, one question? Okay, yeah.
You can come here and ask near the laptop.
Yeah. If any of you guys have a question that you remember only 10 minutes from now, like I always do, you can always just email me, send me a message on LinkedIn. I'm happy to answer whenever.
So if there is any new chain, if there is any new chain which wants to connect with Axelar and use the Axelar tokens to their new chain, I mean, how they can proceed, how they can go forward with it?
Yeah, that's a great question. And it's actually, if I had more time, I would talk about this feature too. Right now, it depends if your chain is like how your chain works. I don't know if it's EVM or if it's like a Cosmos chain you want to connect. But right now, you will have to go through our business development team. We'll have to put you in contact with them and they will help with the onboarding process. But what we wanted to do in the future, to me, is kind of like the holy grail of Axelar, is we're rolling out something soon called the Axelar virtual machine. And that will make it a permissionless process for anyone with a new blockchain to onboard their network into the Axelar ecosystem. And that's how we're really going to scale this ecosystem. So right now, the Axelar virtual machine is still in development. So if you have a new blockchain that you want to onboard to our ecosystem today, send me a message or connect with someone in our BD team, and we will begin the onboarding process. But hopefully in the not too distant future, when the Axelar virtual machine comes out, anyone will be able to onboard their chain into the network without needing to talk to us anymore. I'm very excited for that one.
Hey, hi. This is Arvind.
Hey.
Yeah, hi. So how do you positioning or envisioning Axelar while Polkadot Cosmos is trying the same interoperability side of the story?
Yeah.
So
That's a great question.
how do you see that?
So I had that question first. I remember when I heard about Axelar, I was thinking the exact same thing. I was like, we have really like amazing projects like Cosmos and Polkadot. Here's the difference. And I kind of touched on it a bit, but the difference is universal Web3 interoperability. So right now, Axelar is actually built on top of Cosmos, just to clarify that. So Cosmos uses IBC, which is amazing to interconnect other IBC chains to each other. Polkadot with its parachain model is amazing for connecting via the relay chain parachains to each other. But they're amazing for their own ecosystems to interoperate between blockchains in their own ecosystem. So they've done a really good job. Cosmos with the Cosmos SDK, allowing you to build a Cosmos blockchain and connect it to other Cosmos blockchain. Polkadot with Substrate. What Axelar is trying to do is more universal Web3 interoperability. It's connecting Polkadot chains to Cosmos chains, to EVM chain, to layer 2s, to layer 3s. It's universal Web3 interoperability. It's not just chains within its own ecosystem. It's actually any type of blockchain to each other.
Are you also taking permission blockchains into the scope?
The idea is to have universal blockchain, universal Web3 interoperability. So right now, I can't. I don't think we have any exact permission blockchains, but I know that there are. Like it's something we plan on doing in the future. It's not that we're limited. We're excluding permission blocks.
Like say Hyperledger Besu, which is EVM compatible.
Yeah, right now I don't think we have any Hyperledger based blockchains, but I think in the future we want to keep it as open as possible.
Okay, thank you.
We're definitely now that can exclude anyone.
Bye.
Thank you.
Thank you, Ben. Thank you for joining in.
Cheers, guys. Enjoy the conference. Thank you. And if you have any questions, shoot me an email. I'm happy to talk.
Will
Bye.
do. All right. See you. Bye.